Okay, so we were discussing applications of Bernoulli's equation. Two applications we have discussed. Okay, then we were discussing about blood flow and heart attack. Okay, so the heart attack is also due to Bernoulli's theorem that we applied over there. Okay, so write down. I think I explained this one. So write down. Write down due to due to bad eating habits, due to bad eating habits and lack of exercise plate gets deposited, plate gets deposited on the inner walls of the arteries, on the inner walls of the arteries, on the inner walls of the arteries. So it gets constricted. Constricted means its area of cross-section becomes small. So it gets constricted. So it gets constricted. According to equation of continuity. According to equation of continuity. The velocity of blood inside the artery increases. So the velocity of blood inside the artery increases. According to Bernoulli's theorem, okay, now we will apply the Bernoulli's theorem. Now, according to Bernoulli's theorem, pressure inside decreases. Pressure inside decreases. The outside pressure collapses the artery. The outside pressure collapses the artery. The heart pumps faster. So that the blood again flows inside. The artery. Write down it repeatedly occurs. Which leads to heart attack. It repeatedly occurs, which leads to heart attack. Okay, so in heart attack also, this Bernoulli's equation can be used. Why? Because what is happening? Due to some bad eating habits, okay, and due to lack of exercise, there will be something deposited on the inner wall of the artery. What happens? The cross-sectional area decreases. Cross-sectional area decreases. It means the velocity of the blood inside the artery increases. एक हम लोग को जीते आ जाएगा अब Bernoulli's equation क्या बोलता है? प्लस आपको इस तरह कांस्टेंट V बढ़ेगा तो प्रेशर क्या आ गया अंदर कम हो गया the pressure of the blood which is flowing inside the artery decreases but the outside pressure is the same so outside pressure will collapse the artery आप क्या करेगा जो जो से काम करेगा वापस सिस्टम करना इसके लिए अगले बार होगा क्या होगा है समझ में okay there is one device venturi meter so write down venturi meter we are not going to study in detail about it okay only what is the device okay venturi meter is a device which is used to find out the rate of flow of a liquid what the rate of flow of liquid is volume of the liquid flowing per second rate of flow क्या बोलते हैं volume of the liquid flowing per second so a device which is used to measure the rate of flow of a liquid in a tube is called as the venturi meter so write down a device which is used to find which is used to find the rate of flow of liquid the rate of flow of liquid in a tube the rate of flow of liquid in a tube right now rate of flow of liquid is volume of the liquid flowing per second volume of the liquid flowing per second rate of flow of liquid how do we define it it is the volume of the liquid flowing per second okay so we have completed this chapter whatever is taught only stick to that no extra question of the no extra topic necessary done okay now from the exercise questions which we have to do are okay page number 260 or 269 from the questions question number 2 third is fill in the blanks question the fourth one question based on pressure is equal to force per unit area simple formula we have to use question number 6 based on the height of the liquid in the capillary flow okay which is equal to 2s cos theta upon r rho g which we have already derived in the previous videos question number 7 is again based on the same formula question number 8 is based on Pascal's law small force applied on the small cross-sectional area of system a large force is obtained why because according to Pascal's law the pressure remains constant the pressure which is exerted on a liquid is transmitted equally in all directions question number 11 question number 11 is can Bernoulli's equation be used to describe the flow of water through a rapid in a river can we use the Bernoulli's equation when the water is flowing in a river is it a streamline flow water flowing in a river it's a turbulent flow you haven't seen the previous videos okay what is it it is the turbulent flow and Bernoulli's equation is used only when the flow of the liquid is streamline flow okay so it cannot be used when the water is flowing in a river question number 14 is based on the application of Bernoulli's principle, the one which we have done, the upper surface of the wing is more curved than the lower one. So the pressure on the lower surface will be more, which helps to lift the airplane. Okay, on that only it is based. Question number 15. Okay, now we are in question number 15. Discuss this question. The first group, the liquid is more volume. And in the second phase, okay, here you have to, which of the two figures is incorrect? Which of the two figures is incorrect? This one, the last one is pyramid. Which is correct, which is incorrect? First, use the equation of continuity. यहाँ क्या है cross sectional area is more. Here the cross sectional area is less. Cross sectional area less means velocity will be more. So where is the velocity more? Where the tube is, where the cross sectional area is less. Velocity is less. It means here the pressure will be more. Now use the Bernoulli's equation. Alright. Equation of continuity. Cross sectional area less, velocity will be more. Then P plus half rho v square. Okay, velocity more, so the pressure will be less. So here the velocity is more. Why? Because the cross-sectional area is less. Now use the Bernoulli's equation. As the velocity is less, so at this point the pressure will be more. Pressure will be more means the liquid will rise more in the stream in the vertical tube. So this one is correct. But in the question it is asked that which one is incorrect? B is incorrect. So this one is incorrect. Okay, so B is incorrect, A is correct. Is it clear? Okay, then. Okay, 17 you can do it. This is based on surface energy. One equation we have derived for surface energy. Surface energy is equal to work done upon the surface tension. Then you can do question number 19. You can do it. What is the pressure inside a drop of mercury? Pressure inside a liquid drop. Drop of mercury is a liquid drop only. What is the pressure inside a liquid drop? We have derived its expression. The pressure inside a liquid drop is given by 2s upon r, twice the surface tension upon r. Okay, whenever one free surface is here, the excess pressure will be towards the concave side, that is inside the top, the pressure will be more, which will be 2s upon r. But in case of a soap bubble, how many free surfaces are there? Two free surfaces. There the pressure will be, excess of pressure will be 4s upon r. Okay, but here it is given that mercury drop. Mercury drop, only one free surface. अंदर क्या है पूरा मर्क्यूरी है बाहर क्या है एयर है तो हमने there's only one free surface so the excess of pressure will be 2s upon r. Okay, this formula you have to use it. Okay, question number 19 also you can do it. That is sorry, question number 20. Question number 20 is the excess pressure inside a soap bubble. Inside the soap bubble the excess of pressure will be 4s upon r. How many free surfaces are there? Two free surfaces are there. So the excess of pressure will be 4s upon r. Okay, so note down these questions. So these questions you have to do it in your copy or you can discuss these questions. Okay, now the next chapter, which is thermal properties of matter. Read this chapter. Okay, the next chapter, chapter number 11. Okay, because CBSE has related the major topics of this chapter. Thermal expansion, deleted, transference of heat, conduction, convection, radiation. This year, all these topics are related and the topics which are left that we have already studied in chemistry, specific heat, latent heat, the change of state. Okay, when a solid is heated, first it changes into its liquid state and then into its gaseous state. Everyone knows, no? Okay. So all these topics we have already done in chemistry, so in the physics we are not going to study and go. Is that clear? So chapter number 11 we can start. Okay, now comes chapter number 12. Chapter number 12 is thermodynamics. So let's start with this chapter, thermodynamics. Okay, so here we have to study three laws of thermodynamics. Three laws which were given, we have to study about it. Okay, it is not first, second, third law, zeroth law, first law, second law. Okay, and these topics also, most of the topics we have already studied in chemistry books. But still, as it is there in physics, we are going to study. Okay. So the first one is zeroth law. Before studying zeroth law, one definition we have been studying was this definition, thermal equilibrium. Okay, what is meant by thermal equilibrium? Okay, here very frequently we'll be using system, the word system. Now system here means the gas. Okay, any gas will consider it to be a system. Any gas taken in a cylinder which is fitted with a frictionless movable piston, that inside gas will consider it to be system, and the outside air will consider it to be surroundings. So these two words will be very frequently using system and surrounding. System is the gas which we have taken inside the cylinder, that is the system. Surroundings is the air outside. Okay, that is the surroundings. Okay, now thermal equilibrium means two systems will be in thermal equilibrium when they are at the same temperature. That is, heat does not flow from one system to another. We know that the heat flows from hot body to the cold body whenever they are brought in contact. Is it so? Okay, hot water, you keep it here. After some time, it will come to the room temperature. Why? Because it loses some heat and the air surrounding it is gaining some heat. Okay, so now thermal equilibrium is both are at the same temperature. So there is no exchange of heat. So this we call it as thermal equilibrium. So write down two systems. Okay, it may be two systems or the system of the surroundings. Two systems are in thermal equilibrium. Are in thermal equilibrium. When they are at the same temperature. When they are at the same temperature. That is no flow of heat energy. That is no flow of heat energy. Okay, now we'll study the zeroth law of thermodynamics. Zeroth law of thermodynamics. Just write down. Write down two systems. Two systems A and B. Let us name it as A and B. Two systems A and B are separately in thermal equilibrium. Are separately in thermal equilibrium with a third system C. With a third system C. Then these two systems are in thermal equilibrium with each other. Are in thermal equilibrium with each other. Now you see here, these are the three systems A, B, and C. A is in thermal equilibrium with C. B is also in thermal equilibrium with C. How can they come in thermal equilibrium? If they are separated by some conducting bond. Conducting होगा तो जो ज़्यादा वाला होगा इधर उधर ट्रांसफर हो जाएगा. So these are separated by this one is the conducting bond. It is also called as the diathermic bond. Okay. So A, B are separated with C by conducting bond. Okay, and A and B are separated by insulating bond. So that the heat cannot transfer from one system to the other. Okay, so what happens? A will come in thermal equilibrium with C. B will also come in thermal equilibrium with C. Okay, then it is seen that A and B are also in thermal equilibrium with each other. That is, the temperature of A comes equal to the temperature of C. Transfer. So both will come at the same temperature. The same way, the temperature of B will also come equal to the temperature of C. Then what do we see? The temperature of A will be equal to the temperature of B. That is, A and B are also in thermal equilibrium with each other. Okay, so this is the simple Zeroth law of thermodynamics. Now, before proceeding, first law. The definitions we are going to discuss: heat energy, work done by the gas, and the thermal energy of the gas, because heat comes with Zeroth law fixed. The same way. Two systems, thermal equilibrium, separately with the third system C, then these two will also be in thermal equilibrium. That is, these two will also be at the same temperature. Answer that P is equal to Pc. Or Pc will be equal to understand? Okay, write down. Heat energy, work done, and internal energy. Heat energy, work done by the gas, and internal energy. What is meant by heat energy? Heat is a form of energy. It flows from hot body to the cold body when they are brought in contact with each other. Is it so? So this form of energy we call it as heat energy. So write down heat energy. It is a form of energy. It is a form of energy which is transferred between the system and the surroundings. Which is transferred between the system and the surroundings. If there is a temperature difference between them. If there is a temperature difference between them. What is its SI unit? We are saying that it is a form of energy. What is the unit of energy? Joule. Type of energy, whether mechanical energy, electrical energy, heat energy, all are the same units. That is, the SI unit is Joule. Next, write down work done. Okay, we'll find the expression of the work done. Next, a system is in a cylinder. That is, a gas is taken in a cylinder. Okay, which is fitted with frictionless movable piston. Fitted with frictionless movable piston. Okay, now a force is applied. Either you can think that the piston is moved upwards or the piston is moved downwards. Piston is moved upwards means this gas will expand. Piston is moved downwards means the gas will compress. Okay, in both the cases, some work will be done. It may be done by the gas or it may be done on the gas. That will come later. Okay, so some work is done in compressing the gas or in expanding the gas. Okay, so this work done is equal to force. Suppose you are applying the force inwards, that is compressing the gas, and work done is equal to how much distance have you moved? X distance. So the work done is equal to F into X, formula of work, 14 plus 2. Work done is given by force into distance. Okay, now this force is against the pressure. So it is equal to pressure into the cross-sectional area of the piston. Okay, force is equal to pressure into area. Okay, what is this? A into X. This is the change in the volume. Okay, this much volume is compressed. So what is it? This is the change in the volume. So it is equal to P into change in volume. Let us write it as V. Let the volume changes from V1 to V2. So the work done is equal to P into. So the expression of the work done in case of a gas when it is expanded or it is compressed is given by P into. Okay, so what is the expression of the work done in case of a gas? Like mechanical work, force into displacement. From there only we get it. In case of a gas, in case of a system, the work done will be equal to. No change in volume, no work is done by the gas. Okay, if there is no change, PV is 0. Volume is constant. So no work will be done. Okay, so note down this expression. A small change in the volume, small work done, total work done will be integration. As such, the work done is only due to the change in volume. No change in volume, no work done. You can write down. So what is the SI unit of it? What is the SI unit? Joule. First class primary. The unit of work done is. What is its SI unit? The SI unit of it is also joule. Okay. So this is the work done. So you can write down over there. Work done is only due to the change in volume. The work done is only due to the change in volume. Okay, work done by the gas, on the gas, whatever it is. That is only due to the change in volume. Okay, next the third one, internal energy. The name itself is suggesting the internal energy of the system. We know that gas means it's made up of molecules. So gas, only molecules are there. Okay, so the internal, the sum of the internal energy of the molecules. Now, which type of energy they can possess? Kinetic. Okay. So, which energy? Kinetic as well the potential energy also. So, the summation of kinetic and the potential energy of the molecules of a system we call it as the internal energy. Okay, so internal energy is summation of kinetic energy of the molecules plus the summation of potential energy of the molecules. Is it so? Again, summation of kinetic energy and potential energy of the molecules we call it internal energy. So we just write down like this. Right on. Hence, internal energy is internal energy is the summation of kinetic and potential energy of the molecules. The summation of kinetic and potential energy of the molecules. Okay, now for a real gas, kinetic is also there, potential is also there. But for an ideal gas, we know that the intermolecular forces are zero. Studied history, postulates of kinetic theory of gases. Ideal gas means which strictly obeys Boyle's law, Charles' law, and for that the intermolecular forces are considered to be zero. So what is the potential energy? Potential energy is zero. So for an ideal gas, the internal energy is only the summation of kinetic energy of the molecules. No potential energy exists. Okay, so write down for real gas, real means actually exists. For real gas, both exist. Both means kinetic and potential. For real gas, both exist, but for an ideal gas, but for an ideal gas, no intermolecular forces, no intermolecular forces. So potential energy is zero. So potential energy is zero. Okay, so for ideal gas, internal energy is only the summation of kinetic energy of the molecules. And kinetic energy is a function of temperature. टेम्परेचर बढ़ाएंगे ज्यादा जोर से चलेंगे तो क्या होगा काइनेटिक एनर्जी बढ़ेगा इज इट सो एंड काइनेटिक एनर्जी इज अ फंक्शन ऑफ temperature. Okay, temperature changes, then there will be some change in the internal energy. No change in the temperature, no internal energy. Like we have discussed, volume changes, work is done. Here temperature changes, there will be some change in internal energy. So write down for an ideal gas, internal energy is summation of kinetic energy of the molecules. Write down, and kinetic energy is a function of temperature. And kinetic energy is a function of temperature. Okay, so change in temperature, some internal energy will change. No change in temperature, no change in the internal energy. Okay, now again, before discussing the first law, one more types of process also we can discuss. Isothermal process, one goes isothermal. Name itself is suggested. What remains constant in this process? Temperature remains constant. Okay, pressure and volume will change in such a way that the temperature remains constant. So write down, only write down temperature remains constant. Adiabatic process. Adiabatic. No exchange of heat. Heat remains constant. Okay. So a process in which heat remains constant. No exchange of heat between the system and the surrounding. Isobaric process. Isobaric. That is the unit of pressure. So what remains constant? Pressure remains constant. Okay, a process in which pressure remains constant. The next one is isochoric process. Isochoric process in which what remains constant? Volume remains constant. Okay, isochoric, volume remains constant. Okay, now first law, we'll discuss it tomorrow. Okay, anyhow, I think tomorrow you are not coming, so it will be uploaded. Tomorrow's class will be uploaded. So you can watch it from there.